Hello everyone, this is part 5 video on past year NEET questions from the chapter Some Basic Concepts of Chemistry. Now those who have not taken a look at the first to fourth parts, you can probably do so before going through this, because we would have covered some relevant models of questions in those parts, and we might be borrowing those ideas while discussing the problems over here. We'll start with a question that has come in 1990. This is a question on finding the average atomic weight. In fact, if you look at some of the other videos, you will be able to notice that this model of question has repeated quite a number of times. Boron has two stable isotopes. Boron with atomic mass 10, 19% abundance, and atomic mass 11, 81% abundance. Calculate average atomic weight of boron in the periodic table. Now average atomic weight is basically the weighted average. So weighted average taken by using the abundance. So if you look at the abundance of isotope with atomic mass 10, it is 19. So 19 into 10 plus the abundance of isotope with atomic mass 11 is 81. 81 into 11 whole divided by 100. So we are just taking the weighted average with respect to the abundance. Multiply each of the isotope atomic masses with the respective abundance, add all the sum and divided by sum of the percentages of abundance, which will be obviously 100. So if we simplify this, it will come to 10.81. So the approximate answer is option A, which is 10.8. Moving on to the next question. This is the question that has come in 1989. A metal oxide has the formula Z2O3. It can be reduced by hydrogen to give free metal and water. So they are explaining what is going to be the product of the reduction. Now here we can understand that in Z2O3 the valency of Z will be 3. I mean, we can do the reverse crisscross method. Valency of Z will be 3 and valency of oxygen, as we know, is 2. 0.1596 grams of the metal oxide requires 6 milligrams of hydrogen for complete reduction. Now we need to find what is the atomic weight of the metal. So this is a problem where we will try to analyze the balanced chemical equation for this reduction reaction, and first find the molar mass of this metal oxide, and from there we can find what is the atomic weight of the metal. So if you look at the balanced chemical reaction, Z2O3 plus 3 moles of hydrogen will give 2 moles of Z and 3 moles of water. So this is the balanced chemical equation for the reaction. Now from the balanced chemical equation, what we can see is molar mass of Z2O3 will combine with 3 moles of hydrogen. So the molar mass of hydrogen is 2 grams. So 3 moles means it will be 3 into 2 grams, which will be 6 grams. So as per the stoichiometric equation, molar mass of Z2O3 will combine with 6 grams. And the given information to us is 0.1596 grams of the metal oxide will combine with 6 milligrams of hydrogen, which means 0.1596 grams will combine with, for the sake of having all of the masses in the same unit, we can convert the 6 milligrams also into grams. So 6 milligrams will be 0.006 grams. So stoichiometry is telling us that to combine with 1 molar mass of the substance will require 6 grams, and the given information is 0.1596 grams will require 0.006 grams. Now when we are analyzing the balanced chemical equation, the mass ratio in which these elements or compounds combine, they must be in proportion, which would mean that m by 0.1596 grams will be equal to 6 grams by 0.006 grams. So we can see over here on the RHS, we can multiply both numerator and denominator by 1000. So thereby we will get in the numerator 6000 and denominator will be 6. So totally we'll have 1000. So molar mass will be 0.1596 grams. We'll take it to the other side. It will go to the numerator into 1000. So this will be 159.6 grams. This is the molar mass of the Z2O3. Now when you look at molar mass of Z2O3, it is nothing but the sum of the atomic masses of the elements present, where we have to take into account the number of times each element is repeating. So 2 times X, where we are looking at X as the atomic mass of the element Z, plus 3 times oxygen atomic mass is 16. So totally it will be equal to 159.6 grams, which means 2x plus 16 threes are 48 grams will be equal to 159.6 grams. So from here 2x, we'll take the 48 to the other side. So 159.6 grams minus 48 grams, it will be 111.6 grams. So x will be equal to 111.6 grams divided by 2, which will be 55.8 grams. So this is the atomic mass of the element Z. So the correct answer for this is option D, which is 55.8. Moving on to the next question. This is a question that has come in 1989. Here they are trying to look at the properties of the gas in terms of Cp and Cv. Maybe we will be requiring some knowledge of the gaseous state. Ratio of Cp and Cv of a gas X is 1.4. So this ratio of the molar specific heat capacity at constant pressure to molar specific heat capacity at constant volume, we will call it as gamma, and gamma depends upon the atomicity of the gas. So for the monoatomic, the value of this will be equal to 5/3. For the diatomic, it will be 7/5, which is basically 1.4. So the gas they are talking about here is essentially the diatomic gas. The number of atoms of the gas X present in 11.2 liters of it at NTP will be. So we need to use the molar volume at NTP conditions to find out what is the number of atoms present in the 11.2 liters of the gas at NTP. Now we know that any gas, 1 mole of this at NTP, which is equal to 6.02 into 10 power 23 molecules. This contains 22.4 liters at the NTP conditions. So the given volume is 11.2 liters, which means the number of molecules will be equal to 11.2 liters divided by 22.4 liters into Avogadro number 6.02 in 10 power 23, which will be equal to, so 11.1s are 11.2s, which will be equal to 3.01 into 10 power 23. So this is the number of molecules present, but what they are asking is the number of atoms present of the gas X. Now, since the gas is a diatomic gas, number of atoms will be 2 times the number of moles, or the number of molecules rather, sorry. Number of atoms thereby will be equal to, so the number of atoms will be simply equal to twice of this. So twice of this will be 6.02 into 10 power 23. So the correct answer for this is option A, which is 6.02 into 10 power 23. Now here in this question, we are required to have some kind of an understanding about the properties of the gas to identify what is the gas that they are talking about. So for the monoatomic gas, gamma will be 5/3, diatomic it will be 7/5, and if we have triatomic or polyatomic. In this we have two categories. If it is a linear means it will be same as 7 by 5. If it is a non-linear molecule, then we will have the gamma value to be equal to 8 by 6. So maybe in the gaseous state topic you can take a look at the lecture video to understand how these gamma values are arrived at. So this is a question which correlates the ideas of gamma into the basic concepts of chemistry. Move on to the next question. This is a question that has come in 1989. What is the weight of oxygen required for complete combustion of 2.8 kg of ethylene? So ethylene is basically the common name for C2H4, ethene. And we know the common name for ethane will be acetylene. So ethane is C2H2. So we need to remember these common names also, because sometimes in questions they do give these common names. So what we need to find is what is the weight of oxygen required for complete combustion of 2.8 kg of ethylene. So to solve this, first we need to find what is the balanced chemical equation for the combustion reaction. So C2H4 will combine with 3 moles of oxygen to produce 2 moles of carbon dioxide and 2 moles of water vapor. Now the way we'll get the balanced equation is, first we'll start with the skeletal equation C2H4 plus O2. It is going to give us, since there are 2 carbon atoms, it will give 2 CO2, and since there are 4 hydrogen atoms, it will be giving us 2 H2O. After writing this, we will count what is the number of oxygens on both sides. So on the RHS we can see the number of oxygens is basically 4 plus 2, 6. So we'll require a factor 3 over here. That is how we'll find the balanced equation. Now once we have the balanced equation, we can see in terms of the mass proportion, the mass of 1 mole of ethylene, which is the molar mass, will be 28 grams, and it is going to be combining with the mass of 3 moles of oxygen gas. Each mole of oxygen gas molar mass is 32 grams. 3 moles would be 3 into 32, which is 96 grams. Now we need to find out what is the weight of oxygen required that will combine with 2.8 kgs. So this X is what we need to find. Now most of the problems in this balanced chemical equation analysis will be on the proportion method. So what we have is 28 grams will require 96 grams and 2.8 kg requires X. We need to find what is the value of X. So X by 2.8 kg will be equal to 96 grams by 28 grams. We can see the unit gram will be cancelled. So we'll have X is equal to, we'll take it to the right side, 96 divided by 28 into 2.8 kg. So the X value will be coming in kilograms. Now we can see over here 2.8 ones and 2.8 tens, because 2.8 in 10 will be 28. So what we have is 96 by 10 kilograms, which is equal to 9.6 kg. So the weight of oxygen required for the complete combustion of 2.8 kg of ethylene is 9.6 kg. Option C is the right answer. Moving on to the next question. This is the question that has come in 1989. The number of oxygen atoms present in 4.4 grams of CO2. Now CO2 molar mass will be 44 grams. Now the number of moles of CO2 here will be equal to the given mass 4.4 grams divided by the molar mass 44 grams, which is equal to 0.1. That is the number of moles of CO2. Now each mole of CO2 contains 2 moles of oxygen atoms, which would mean that the number of moles of oxygen atoms will be equal to 2 into 0.1, which is equal to 0.2. So the number of oxygen atoms itself will be equal to 0.2 into Avogadro number, which will be 0.2 into 6.02 into 10 power 23. So what we'll have as answer is 1.2 approximately into 10 power 23. So the number of atoms of oxygen present in 4.4 grams of CO2 will be 1.2 into 10 to the power of 23. So the correct answer is option A. Moving on to the next question, this is a question that has come in 1988. At STP standard temperature and pressure conditions, we need to find the density of CCl4 vapor in gram per liter. So this is also important. What is the unit in which they are asking? Now, if we take 1 mole of CCl4, the mass of this at STP conditions we are looking at will be carbon atomic mass is 12 grams plus there are 4 chlorines, 4 into 35.5 grams. So 12 plus 4 into 35.5, it will be 142 grams. Total it will be 154 grams. This is the molar mass of CCl4, carbon tetrachloride. Now 1 mole of CCl4 at STP will be occupying a volume of 22.4 liters, which is what we call as the molar volume of the gas at STP. So thereby the density will be mass, which is 154 grams divided by the volume, which is 22.4 liters. And on simplification, we will see that the value will somewhere come close to 6.87. So the correct answer for this is option A, which is 6.87. We have taken the mass in grams and volume in liters. So move on to the next question. This is the question that has come in 1988. 1 liter hard water. Hard water contains the soluble magnesium and calcium ions. So 1 liter of hard water contains 12 milligrams of Mg2 plus ions. The milli equivalents of washing soda required. So washing soda is basically Na2CO3. So we have 10 water molecules, but we can take it as Na2CO3. We need to find out what is the milli equivalents of washing soda required to remove this hardness. Now before we go on to discuss about this, we need to understand the idea of analyzing a reaction based on the equivalents. So whenever, let us say, a substance A is reacting with say another substance B, they will react in such a way that one equivalent weight of the substance will exactly react with one equivalent weight of the substance B, because equivalent weight will be the mass of the substance which will be able to exchange 1 mole of electrons. So this will exchange 1 mole of electrons, which is in return exchanged by the substance B. Now to find out equivalent weight, we have different approaches. So for the acids or bases, the equivalent weight will be equal to the molecular weight by basicity or acidity. For the salts, equivalent weight will be equal to the molecular weight divided by the charge on cations or anions, because both of them will be having the same charge. And for the ions, equivalent weight will be equal to the atomic weight. So we are talking about the single ions divided by the valency. So valency is nothing but the charge that they will carry. So here when the Mg2 plus ions are reacting with washing soda, what we see is Mg2 plus ions are reacting with washing soda. One equivalent of this will react with one equivalent of Na2CO3. Now the Mg2 plus amount is given not in terms of equivalents, but it is given in terms of mass. So if you look at the Mg2 plus ions, the equivalent weight of Mg2 plus ions, we're talking about the Mg2 plus ions. Magnesium atomic mass is 24 grams divided by the valency is 2, so it will be 12 grams. Now 12 milligrams of Mg2 plus would mean 1 milli equivalent, because equivalent weight is 12 grams. We have 12 milligrams means number of equivalents we can calculate. It will be 1 milli equivalent. So 12 number of equivalents will be 12 milligrams by 12 grams, which is equal to 1 by 1000 equivalent. That is what we call as the milli equivalent. So 1 milli equivalent of Mg2 plus ions is going to be exactly reacting with 1 milli equivalent of the washing soda, which is Na2CO3. So the correct answer for this is option A, which is 1. Moving on to the next question. This is a question that has come in 1988. 1 cc N2O at NTP conditions. So we are given 4 options. Of course, the fourth one is just saying all of them. So if you look at the options, in option A, they're talking about it contains how many atoms. Option B, they're talking about it contains how many molecules. Option C, talking about how many electrons it contains. And if all of them are satisfied, then probably the correct answer will be option D. So we'll take a look at it. We know that at the NTP conditions, 22,400 cc of any gas will contain 6.02 into 10 power 23 molecules. Now 1 cc will contain how many molecules? 1 cc will contain exactly 6.02 into 10 power 23 by 22,400. So we can see that the option B is being satisfied. The number of molecules will be 6.02 into 10 power 23 divided by 22,400. Now coming to the number of atoms, if you see N2O as a molecule, it is a triatomic molecule, means every molecule will have 3 atoms. Now the given volume of the N2O, which is 1 cc, will contain the number of molecules is 6.02 into 10 power 23 by 22,400 into 3 will come, because we are finding the number of atoms. So on simplification, we'll see that this will be 1.8 into 10 power 22 divided by 224. Now we're trying to simplify it in a form that they are basically giving. So we can see that the number of atoms is also matching, and by now itself we can judge, because we are just going to be having one correct option. The option could be option D, but anyway we'll check in terms of the electrons also. We see that N2O will contain 7 for each of these nitrogens, so 7 plus 7 plus oxygen 8, totally 22 electrons. So these are the number of electrons present in one molecule. Now we have the number of molecules over here, so the total number of electrons, if you want to find the total number of electrons, it will be equal to 22 into the number of molecules, which is 6.02 into 10 power 23 divided by 22,400, and on simplification we'll see that this will be coming close to 1.32 by 224 into 10 power 23. So which means option C is also satisfied. So the correct answer for this is option D, which is all of these. Now this is the past year NEET questions series on basic concepts of chemistry. Hope you find it useful, and For more clarity on the concepts, you may refer to our lecture videos as well. All the very best.